Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 11D. Myself, Ishita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and JR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being held in a hybrid mode. The physical event was held day before yesterday in Pune, India, and the virtual event is being held through Zoom from the 19th till the 21st of January 2026. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chair. We have with us Dr. Janali Jasmine Jaina, who is an assistant professor in the School of Computer Engineering at Kalinga Institute of Industrial Technology, KIIT, Odisha, India. Her research interests include machine learning, self-computing, methods for pattern recognition, evolutionary algorithm for optimization problems, and data analytics, reflecting focus on developing intelligent and efficient compilation solutions. We welcome you, ma'am. We'll be beginning with our papers. I have a first presenter, Chetna Shirvage, with the paper titled A Novel Lightweight CNN Architecture for Accurate Classification of ECG Images and Cardiovascular Disease Diagnosis. Ma'am, if you're ready, then you may start with the presentation. Ma'am Chetna, it seems we do not have her. I'd like to call upon our next presenter. We have with us Tramane with the paper titled Agent-Based Modeling of Household Energy Consumption in the Districts of Ouagadougou. So if you're ready, then you may start with the presentation.
I'm stud I'm PhD student in Nazi Boni University, specifically in Burkina Faso, West Africa country. The presentation topic as follows: agent-based modeling of household energy consumption in the district of Ouagadougou. The agenda in the presentation, we have an introduction, a description of model, and the first part, conclusion and perspective. The first part, an introduction, the challenge. What an improvement in living conditions in Ouagadougou City. Ouagadougou City is the political capital in Burkina Faso. Many electrified households now use household appliances. So the use of this new equipment creates a new energy need. Ouagadougou City is a city Wi-Fi has population density and strong household energy demand. According to the fifth General Census of Population and Housing, the city population is estimated at over 2 million inhabitants. Another factor is the climate. The city of Ouagadougou is characterized by an extreme outer period. The temperature varies from 32 to 42 degrees Celsius. The problem, what is the problem? The problem, there are the district of Ouagadougou Wi-Fi the highest energy consumption from residential use. The research objective of the study. We have to propose a conceptual model for electricity consumption across districts. To simulate using gamma platform the electrical consumption of urban households in district. and we identify the district that consume the most energy. The modeling approach for energy consumption. There are several modeling studies for energy consumption. Firstly, the characteristic of household appliance. We have only one and all have studied the estimating residential electricity consumption in Nigeria to support energy transition. Tariful and Allah has studied the efficiency of household electricity consumption in Ghana. The second part, the second part, climate variation influence energy consumption. Berkouver has studied heating and the effect of temperature on household electricity consumption in South Africa. Ye and Allah have studied the effect of temperature on household electricity consumption evidence from South Africa. What is the choice of approach modeling? We choose the multi-agent approach because the multi-agent approach is based on agent. It allows the interaction between agents. It allows the implementation requires the use of multi-agent platform. The second part is the description of the model. For the description of the model, use the protocol the ODD protocol. Because the ODD protocol standardizes the use of agent-based model, it, it allows to make up the description of the model understandable. The tool user. We have a free tool, Gamma platform for the simulating of the model, Excel with data analysis and visual paradigm of a build of diagram. We source data. We have a four data source. The info climate database, the monograph of Ouagadougou 20 2021 Burkina Faso demographic and ILVA survey final report 2019 population and using census of Ouagadougou city. The hypothesis of description of model. Firstly, the household belongs to a household type. With half of its equipment. The use of equipment by the household is based on a probability of use. The probability of equipment used by household depends on the time of day of the week. The dwelling is occupied by household. The fifth, for the initial scenario of the simulation, we define an initial number of household for each district. We have a model diagram for the design concept. For the study, you have five equipment. We find the air conditioner, the fan, and the lighting. Each equipment is characterized the energy need and appropriation for each type of household. The C model for evaluator The energy need of Ashloader, we have defined the following formula. Ni Ashloader égalité somme pi aya multiplication number I. For evaluate the energy consumption, we have the formula consumption Ashloader égalité somme energy aya multiplication probability I. The simulation, we have a configuration. The period, we have particular interest in the auto period from from March to May. We have a significant impact of solar energy consumption in Ouagadougou city. The climate data, we collect from the InfoClimate database and cover the period from 22 to 2024. Computing resources, we have a user Gamma platform version 2025 25 gigabit RAM, 8 terabit of storage capacity. The simulation, the property of the model. The simulation is done every 1 year. The simulation span over a week. The climate period at period. Three simulation scenario. Type 1, type 2, and type 3. We have the number of ash loader by type of district.
Excuse me, sir. I'm really sorry to
Yes?
interrupt you, but I'd like to remind you of the time limit.
Okay, okay.
Yeah.
The result of simulation. We have the result of the first scenario. We have observed data the district 1, 10, free are the largest energy consumer. The result of the simulation on second scenario for the type 2. We have 12, 8 to consume. We have we observe data the district 3, 9, and 1 are the largest energy consumer. For the first scenario of type 3, we have the district 3, 9, 6 are the largest energy consumer. Conclusion. The achievement of the study simulated the overall behavior of model in Gamma platform, visualize the result of model simulation. We feature direction, we, we extend the study to the regional and national scale. We evaluate the energy consumption of industry and the service sector in the city of country. A reference that concludes my presentation. Thank you. Hello, that
Yes,
concludes
sir.
my
Yes,
presentation.
sir. Yeah. Ma'am, would you like to ask any question?
No question from my side.
Okay. We'll be proceeding on to our next presenter. I'd like to call upon our next presenter. We have, just a second, Pranda R with the paper titled AI-driven multimodal diagnostic framework for early skin cancer detection and predictive teledermatology applications. Ma'am, if you're ready, then you may start with your presentation.
Yes, ma'am. Just a minute, ma'am.
Sure.
Good afternoon, everyone. Myself, Brenda. My paper project is AI-driven multimodal diagnostic framework for early skin cancer detection and predictive teledermatological applications. Introduction is timely identification of skin-related malignance continues to be a pressing global issue, especially in locations where specialized diagnostic services, and experts dermatological care are scarce. This study presents an intelligent diagnostic framework that integrates artificial intelligence, machine learning, and image processing techniques to enable early and automatic detection of malignant and benign skin conditions. The proposed AI-driven framework supports early detection, enhanced dermatologic triaging, and exhibits strong potential for teledermatological applications in both urban and rural healthcare ecosystem. The problem statement is the proposed skin lesion detection and classification framework is developed to enable a complete and systematic analysis of dermatological images collected from both clinical and non-clinical environments. The objective of this framework is to provide a reliable, standardized, and consistent diagnostic process that assists healthcare practitioners in identifying various types of skin lesions accurately and efficiently. The literary surveyor here are Estival 2017 Nature, dermatologically level classification of skin cancer with deep neural networks. Here, the metrics are first work to demonstrate dermatologically level performance using deep CNNs. Use transfer learning trained on very large data sets. Covered multiple skin diseases, not limited only to melanoma. Strong clinical relevance, benchmarked directly against the expert dermatologists. Dermits. Training datasets was not publicly available, limiting reproducibility. Black box nature of deep learning, limited expandability. Performance may vary across population and image devising. The performance are for melanin versus benign, comparing sensitivity and specifically to board certified dermatologists. Set the foundation for AI-based dermatologist diagnosis. The second one is Cordella 2018 ISBI challenge. Skin lessons analyzed towards melanin direction. The merits are introduced a standard benchmark challenge ISIC 2017, enables fair comparison of algorithms across segmentation, feature extraction and classification, encouraged open datasets and reproducible research, showed effectiveness of both deep learning and hybrid approaches. Dermits are dataset size still relatively small compared to real clinical diversity. Results highly depend on pre-processing and segmentation quality. Performance varied significantly across participating methods. The performance best challenge submission achieved AUC 0.7 to 0.91. CNN-based approach outperformed traditional handcraft features, highlighted gaps between experimental and clinical performance. The third one is Texture 2018 scientific data, the HAM 1000 dataset, 10,000 dataset. Merits, large publicly available dataset, includes 7 different pigmented skin lesion classes. Events collected from multiple sources, improving variability. Became a standard dataset for training and benchmark models. Dermits. Class imbalance, example, fever, melanin classes. Limited clinical metadata. 8. Sex and lesson history. Dermoscopic images only, no clinical photography. Performance. Dataset itself does not present a model, but CNN trained model and HAM 10,000 typically achieved AUC 0.85 to 0.93, widely used to validate robustness of deep learning models. The fourth one is Garnavi 2012 IEEE ITV, computer-aided diagnosis of melanoma using border and velvet-based texture analysis. Merits strong handicrafted feature engineering, good interpreter and low computational cost. Effect at the time when deep learning was not dominant. Clinical inspired features align with ABCD melanon rule. Dermits. Performance heavily dependent on accurate lessons segmentation, limited scalability and generalization to large diverse datasets, outperformed by modern deep learning approaches. Performance is classification accuracy around 80 to 85%, sensitivity and specific competitive for its time, demonstrated feasibility of automated melanin detection pre-CNN area. These are the overall comparative summary. The proposed framework. This stage prepares a raw image of analyzing by improving their quality and consistency. Normalization. Pixel values are scaled to range of 0 to 1 for stable computation. Resizing. All images are resized to 128 into 128 into 3 pixel for uniformity. Noise removal. Median and Gaussian filter reduce noise while preserving edges and lessen borders. Constraint enhancement, histogram equalization improves the visibility of lessons area. Color correction, algorithm adjusts highlighting and color balance to ensure consistent appearance across images. Result, clean, high quality and standardized lesson image ready for feature extraction. Implementation and result, dataset preparation, CNN architecture, system integration and workflow. Feature extraction. After preprocessing key image features that distinguish bending from malignant lesions are extracted. Features include shape, color, edge, irregularity, and texture partners. Quantitative analysis follows the ABCD rule, asymmetric, border, color, and diametric. Mathematical filters and kernels convert these visual partners into numerical feature matrix. Classification. This phrase classifies lessons using the extracted features, models from binary classification or multi-class. Example, melanin, BC, and SCC. Decision borders are created using optimized and statistical analysis. Each image is a probability score for different lesson types. Result, accurate prediction of lesson categories with confidence scores. The system combines classification result with patient metadata, age, lessons, location, and exposure history. Regenerates a diagnostic report with classification results and confidence levels. Heat maps and color overlaps highlight important regions influencing the diagnosis. Aim to support clinics with interpretability evidence-based result. Here we get a clear data-driven insights to guide medical decision. Deployment. The final stage ensures real-world usability of system, compatible with desktop, mobiles, and embedded devices. Using lightweight processing for real-time performance, even a limited hardware enables deployment in remote healthcare centers and teledermatological networks. The dataset preparation to ensure reliable and accurate classification. A diverse and high quality dataset was prepared. Sources, public dermatological dataset, ISIC, HAM 10,000 and PH2 plus real world images captured via mobile cameras under different lighting conditions. Classes, class 0, benign moles. Class 1, malignant. Expert validation. All images were reviewed and labeled by dermatologists to ensure clinical accuracy. Pre-processing. Resize to 128 into 128 into 3 pixels for constancy. Min-max normalization to balance lighting and contrast. Data augmentation to increase dataset diversity and model robust. Result, a large, balanced and standardized data set is suitable for CNN architecture. A lightweight CNN was developed to classify skin lesion efficiently. That is, The convolutional neural network. Network structure input 128 into 128 into 3 color images. Convo layer 32 filter 3 into 3 kernel. Max pool 2 into 2 pooling. Convo layer 64 filters 3 into 3 kernel. Output layer 1 neuron sigmoid activation for binary classification. Training setup loss function binary cross entropy. Model accurately distinguishes Benlin and Magnet lessons with high generalization capability. A system integration and workflow. After training, the CNN model was converted to TensorFlow for real-time deployment. The figure 5 shows that the image capture PI camera captures the skin lessons. Preprocessing, OpenCV normalizes an enhanced image. In classification, the TensorFlow Lite CNN model predicts lesson type. The output is probability score displayed on the screen, benign or malignant. Deployment advantages are real-time interface, low power consumption, portable for remote tele-dermatological application. The results are efficient deployed AI-based for early skin detection in real-world setting. Here I come to conclusion. The conclusion, the CNN achieved an accuracy of 92, precision of 0.90, recall of 0.94, and F1 score of 0.92 on the validation dataset. Table 1. Comparatively, analysis shows CNN outperforming all classical ML algorithms. KNN 81%, NV 78%, LR 84%, and SVM 86%. Models showed inferior generalization capabilities. The CNN performance underscore its potential for real-time deployment on edge devices such as Raspberry Pi. The system is computationally effective and supports low latency interference, enabling its use in mobile diagnostic platforms. The Derma AI model balances between precision and recall demonstrate consist National Cancer Institute Melanin Statics 2023. Its integration into teledermatologic systems may significantly reduce delays in diagnosis and improve patient outcome. References are A is N.C. Condella, Garnavi, and Alban. Thank you. Hello.
Yes, ma'am. Ma'am, would you like to ask any question?
Yes,
No, ma'am. Okay. Sorry,
just
ma'am.
one question from my side.
Yes, ma'am.
That
Yes,
is,
ma'am.
you just found out that in CNN model the accuracy increased. Can you just give some idea why you think the accuracy increased from the normal machine learning models, and why the accuracy increased? Like it's about like 92 some percent you are getting. So why you think so? Why it increased?
Ma'am, the surge in accuracy while using the CNN, ma'am, or traditional machine learning models, especially for image, video, and spatial data, is primarily due to their ability to automate features extraction, understand spatial context, while traditional models like SVM and or random forest often rely on manual, ma'am, handcrafted feature extraction.
Okay.
So the CNN.
So have you used the feature extraction, any feature extraction technique in any of the traditional models, what you have told?
Yes, ma'am.
Which feature extraction technique you have used?
Um,
Okay, so that actually you have also not mentioned in the PPT too, whether you have used any feature extraction techniques or not. Okay, that's all from my side. Thank you.
Thank you, ma'am.
Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to call upon Tony Bayan with the paper titled EEG Signal Processing and Machine Learning Techniques for Mantra Chanting, a Systematic Review. So if you're ready, then you may start with your presentation.
Yeah, am I audible?
Yes, sir, you're audible.
Okay, let me share the screen. Is the screen visible?
Yes, sir, it is visible.
Okay, thank you. So good everyone. Good afternoon, everyone. Sorry. So I'm Tony Bayan from the Department of Information Technology, Guwahati University. Today I'll be presenting our review paper titled EEG Signal Processing and Machine Learning Techniques for Mantra Chanting, a Systematic Review. Okay. So these are the contents today we'll be discussing about. So why mantra chanting, the contribution of our work, the literature review, uh, followed by the summary and key observations, and we'll finally conclude. So the human brain is one of the most complex biological systems, and stress-related mental health challenges such as anxiety, depression are increasing. Meditation and mantra chanting have been practiced for centuries as techniques for mental calmness and emotional regulations. In this case, electroencephalogram, that is EEG, uh, is a technique by which we can measure the brain's electrical activities. Now, this EEG can be both invasive and non-invasive. We prefer non-invasive EEG as it does not require any surgery, and also it is cheaper. EEG is used to detect the electrical signals of the brain by the use of electrodes that are surfaced on the scalp. So basically, brain waves are divided into 5 frequencies, namely alpha, beta, theta, delta, and gamma. And here we have a table that basically states the psychological state along with the frequency in which they fall. In our case, since we are surveying or reviewing the mantra chanting part of the thing, the mostly the alpha and the theta band are responsible for conscious and the relaxed state of the mind. Now, why mantra chanting? So, mantra chanting meditation is one technique in which a sound or a word, basically called as a mantra, is recited either aloud or silently during meditation. Mantra chanting have been in practice and used for regulating the body and the mind. Also, it is believed that meditation mantra plays an important role to achieve a peaceful state of mind, reducing stress, and helps in improving the attention. So, in our study, we have found that there is a lack of a standardized EEG, machine learning, deep learning review. So, this study mainly aims to study the EEG signal processing with respect to mantra chanting. We present a methodological exploration of the use of machine learning and deep learning for EEG analysis, particularly with respect to mantra chanting. So EEG analysis generally follows a structured pipeline. So firstly, signals are being acquired and then pre-processed, and then we can further analyze the data. Now, pre-processing involves several steps. As we can see, the first one is artifact removal. Now, these artifacts can be of various types. Artifacts such as blinking of the eye and noise. Basically, these are noise that needs to be removed. In this figure, we have two plots, figure point A and point B, where A represents the raw EEG data, and here the red bounded box is basically some spikes that we can see in the EEG signal of different channels. So here we are considering 32 channels, and these spikes actually needs to be removed, or because these are noises, we need to remove, and after this we get the filtered EEG. Now, for removing noise, we have algorithms, various algorithms such as band pass filtering, notch filtering, etc. Next, we have the segmentation. In segmentation, what we do is we segment each EEG signal, because EEG is a continuous signal. It's a large data. So we need to segment the data so that we can process or extract meaningful information from that particular signal. Next, we have feature extraction. Feature extraction basically transforms the raw EEG signal into informative uh, representations. For feature extractions, we have different various feature extractions. So we have time domain features, we have frequency domain features, to name a few. So this study is basically showing the different various machine learning and deep learning approaches over the period 2018 to 2025. So early studies have used classical machine learning algorithms, but recent study increases the use of deep learning and multimodal EEG analysis. So these are some papers that we have streamlined depending on the methods that used and the papers that have reported these methods, both using machine learning and deep learning. Here you can see various machine learning and deep learning approaches that have been used. As we can clearly see that SVM uh, has been extensively used over the decade. But yes, nowadays CNN and deep learning algorithms also plays a vital role. So the key observations from our study is that mainly the alpha and the theta band are the most consistent marker when we consider mantra chanting and mainly the relaxation of the brain. And we also see that there is a lack of a data set and standard protocol for recording these EEG signals. So I would like to conclude with the statement that EEG-based machine learning provides a powerful framework for studying mantra chanting. Also, ancient meditative practices can be objectively analyzed using modern AI techniques. And this work will provide a new perspective to the study of EEG data analysis with respect to mantra chanting. Thank you.
I have a question here.
Yes, ma'am.
You said that there are very few papers, literature review
Correct.
papers on the application of mantra chanting and to study what's the effect of body and mind. So, is
Correct,
it
ma'am.
the sole motivation, or there is something else you found out from these papers?
No, the mainly we have various. If we mainly see the literature, there are various papers cited uh, for body and mind and for mantra chanting. But in our study, we are mainly confined with the mantra chanting and the techniques that are used to study the EEG analysis regarding the mantra chanting. So that basically,
So, you were telling that your review is exclusively to mantra chanting only.
exactly, ma'am. Yes, ma'am.
And what are the basic common techniques you found out which were used and which had a good accuracy in detecting the effect?
All deep learning algorithms, there is a problem actually. Since we don't have a large data set, mainly deep learning algorithms works best when the data set is huge.
Yes.
So in our case, in our study that we have already studied, we have found that machine learning algorithms achieves a great accuracy percentage. To be precise, we have also got papers that achieve 99.2% accuracy
Mm.
for classification. But in deep learning, that is less with respect to machine learning algorithms.
Mm.
We also like to happy actually we have already collected the data and we have published a paper in IEEE data descriptions
Mm.
for the data set that we have created for mantra chanting.
Okay, so you have created your own data and
Correct.
more samples are there. So what?
Yes, ma'am.
Okay, now, so don't you think that key traditional machine learning algorithms perform better?
Uh, Ma'am, to
Or we
be
should
very
prefer traditional machine learning algorithms when we are going for this type of innovative things where we don't have so many data sets available. So, or samples available. So we can go for the traditional machine learning algorithms rather than the deep learning algorithms.
no, traditional machine algorithms is best. That's not a problem. But the thing is, since deep learning algorithms are prevalent as of now, so we have already tested in our data and we have achieved better accuracy than the machine learning algorithms in our case.
Okay, okay, that's all from my side. Thank you.
All right. Thank you. Thank you so much, ma'am.
Thank you, sir. Thank you, ma'am. We'll be proceeding ahead with our next paper presenter. I'd like to call upon, we have next Kuljit Kaur with the paper title Green and Smart Communication Systems, Digital HR Communication Tools, Reduced Emotional Labor. Ma'am, if you're ready, then you may start with the presentation.
Okay. Good afternoon, all. My name is Dr. Kuljit Kaur. I am Assistant Professor, Sardar Bhawan Singh University,
More signature
Dehradun,
Good like you, sir.
So I'm presenting on topic Green and Smart Communication System, Digital HR Communication Tools.
আচ্ছা আচ্ছা মই আপোনাক দিলে চাই হ'ব নেকি বা আপুনি ডাইৰেক্ট টনি বেন বুলি লিখি দিলে কথা নাই টনি বেন
Okay, fine. So I'll repeat my topic. My topic is Green and Smart Communication Systems, Digital HR Communication Tools, Reduce Emotional Labor. So I'm presenting this on behalf of my colleagues. So the background of this topic is HR professionals regularly deal with emotionally intense interactions such as grievances, onboarding, and performance discussions. This continuous emotional regulation leads to stress, burnout, and emotional dissonance. At the same time, organizations are increasingly adopting digital and green HR communication systems like HRIS and AI chatbots. However, limited research connects digital HR tools with emotional labor, reduction, and sustainability together. This motivates our study. The objective of this research is there are four key objectives. First is to examine the role of green and smart HR communication systems. Second is to understand how these systems help reduce emotional labor among HR professionals and employees. and third is to and the third is to analyze their contribution to employee well-being. Finally, we propose a conceptual framework linking digital HR communication with organization sustainability. Now, the next slide is what is emotional labor in human resource management? Emotional labor introduced by Hochschild refers to managing emotions to meet organization expectations. In HR, emotional labor is especially intense due to frequent interactions involving conflict, feedback, and employee support. HR professionals often engage in surface acting and deep acting. Over time, this leads to emotional exhaustions, burnout, and reduced job satisfaction. The next slide is related to digital and intelligent HR communication, which includes EHRM, that is electronic human resource management, HRIS, AI chatbots, and employee self-service portals. These systems automate routine HR tasks such as leave request, payroll queries, and onboarding information. Automation improves efficiency, consistency, and accessibility. Importantly, it reduces repetitive emotional demanding interactions for HR professionals. Next is digital HR and emotional regulations. Digital HR tools act as emotional buffers, standardize response, and reduce face-to-face interactions, lower emotional strain. Features like anonymity and asynchronous communication provide psychological safety to employees. According to the job demands, resource models, these tools function as job resources that reduce emotional demands and enhance well-being. Now, what is green HRM sustainability? Green HRM emphasizes environmentally responsible HR practices. Digital HR supports green HRM by promoting paperless communication and reducing travel. This aligns with green IT principles that to reduce the wastage of paper. Beyond environmental benefits, it contributes to economic efficiency and social sustainability, especially employee well-being. Research methodology, this is a conceptual study based on secondary data. We conducted a systematic literature review using database like Scopus, Web of Science and Springer, etc. Literature related to emotional labor, digital HRM and green HRM was synthesized. Since no primary data was used, the study focuses on theory building rather than empirical testing. So this is a proposed conceptual framework. Our conceptual framework positions green and smart HR communication system as job resources. Through automation and standardization, emotional labor is reduced. These leads to improved employee well-being, job satisfaction, and engagement. Ultimately, these outcomes support organization sustainability at social, environmental, and economic levels. The key results are the literature synthesizes shows a reduction in routine emotional interactions due to automation. Emotional dissonance and burnout among HR professional decreases. Employees experience higher satisfaction and engagement. Organizations also benefit through improved efficiency and reduce environmental impact. Our findings suggest that digitalization does not eliminate emotional labor but reshapes it. HR professionals engage less in routine emotional work and more in meaningful interactions. This supports emotional labor theory and extends the JDR model. Digital HR systems emerge as strategic organizational resources. So the conclusion of this study is the study concludes that green and smart HR communication systems effectively reduce emotional labor. They enhance employee psychological well-being and engagement. At the same time, they contribute to sustainable organization performance. These insights are valuable for HR managers, policymakers, and researchers. Now, the future, a little about the future research directions. Future studies should empirically validate this conceptual framework. Industry specific and longitudinal research can provide deeper insights. Organization culture and digital literacy may act as important moderators. Ethical implication of AI based HR system also requires attention. Thank you. This is all from my side.
Okay. I just want to know what's the key takeaway? What's the like you figured out the key highlight of your work?
And that using the like automation these tools actually reduce the emotional labor, the monotonous work of the employees get reduced by using the automated tools. The different AI chatbots are there. They reduce the redundancy of the work.
So, do you really
Anything.
feel this AI intervention better than the human interventions?
Ma'am, we cannot say that it is better, but somehow it is really useful when when the nature of the work is monotonous. Then when there are repeated actions we need to take, and so it helps to reduce that.
Okay. Okay, fine. Thank you.
Thank you, ma'am.
Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to call upon Venkata Hemlatha with a paper titled Green Cube Carbon Aware Scheduling of AI Workloads in Kubernetes Using GCM and BCAS Algorithms. Ma'am, if you're ready, then you may start your presentation.
Is my screen shared?
Yes, ma'am, it is visible.
Okay. So Good afternoon, respected chairs, reviewers, and participants. I am Hemalata, and today I will be presented our work titled Green Cube Carbon Aware Scheduling of AI Workloads in Kubernetes using GCM and BCA's algorithms. This work focuses on reducing carbon emissions produced by AI workloads through intelligent scheduling in Kubernetes. So, so I will begin with a brief introduction. So I'll begin with a brief introduction followed by the problem statement and motivation. Then we will further proceed to the methodology implementation, and the major focus of the presentation will be on the results and limitations. So coming to the introduction, I would like to give a brief explanation on the Docker container images and containers. So the Dockers are a platform to package and runs the apps in portable units, that is containers. In container, they run the instance of an image which has fast lightweight isolations, where the containers images are a blueprint with apps and development with version layers. Kubernetes is an orchestrator that schedules, heals, and scales the operators. We are majorly focused on green AI, which practices to reduce the usage of carbon emissions when the workloads run and where it runs, so to maintain efficiency. So coming to the introduction, our modern AI workloads are increasingly developed using containerized environments. Docker allows applications to be packaged and into lightweight containers with all dependencies. Kubernetes orchestrates these containers by handling scheduling, scaling, and recovery. Common Kubernetes objects include pods, deployments, jobs, services, and config maps. Along with this, Green AI emphasizes reducing energy consumption and carbon emissions, not only by optimizing models, but also by deciding where and when workloads are executed. So, coming to our motivation of this project, AI workloads are growing rapidly, and so is their environmental impact. Even small scheduling decisions, when repeated at scale, they can lead to significant carbon emissions. So, our motivation is to introduce carbon intelligence into Kubernetes scheduling without breaking the existing workflows, but also respecting the performance constraints. So, this is the problem statement where we would like to brief about our problem. So, here we address that the default Kubernetes scheduling can unknowingly place workloads on high carbon grids. We need a green aware scheduling mechanism that minimizes carbon emissions, and it also balances the SLA and latency constraints. So, it remains compatible with the standard Kubernetes pipelines. This forms the core problem of the work. So, coming to the real time application, what we have approached and inspired by Microsoft Carbon Aware Kubernetes on AKS, which is a real world deployment. So, Microsoft reduces the emissions by shifting workloads temporarily while running the jobs at cleaner times, and spatially by running the jobs in cleaner regions. So, coming to the temporal shifting, it basically about where the carbon emission can be lower during the daytime or at a night time or at a particular time zones. And spatially shifting refers to the region like US North or AP South. So this validates the practicality of carbon aware orchestration in production of the environments. So coming to the mapping of the Microsoft AKS to the GCM and BCAS algorithms. So GCM refers to the global cost minimizer, which is a carbon aware scheduling algorithm, which selects the regions with the lowest carbon intensity. Coming to the BCAS, which is the balance carbon and the SLA, it is a policy layer which ensures service level objectives and not violated. Microsoft describes this as carbon aware, not only carbon only, which directly corresponds to a alpha weighted BCS model, balancing emissions and latency. So the literature review, what we have focused on, currently existing energy efficient data centers, and the major domain focus is on cloud computing, Kubernetes scheduling, and sustainable computing. So the work done in our paper, we have proposed a carbon-aware scheduler that places the pods on nodes, and it is highly about the renewable energy sources while reducing the emissions and also maintains the performance. So the research gaps and challenges addressed among the papers are they mostly everyone is focused on scheduling, but also the life cycle of the container images. But it is very limited to the real world validation. But it does not explore the integration of the green AI approaches. So since we have addressed these challenges in the papers, it extends by linking with the green AI, and also it executes the container image lifecycle and Kubernetes. This paper solves us to where we look while running and how to manage our container images and how to schedule it. This whole pipeline is sustainable. So coming to the methodology overview and our system architecture. Our system is implemented using Docker images orchestrated by Kubernetes. So we consider the carbon data provider, carbon aware scheduler, and AI inference workload. All components interact using the native Kubernetes primitives. Coming to the data model, the diagram shows the end-to-end workflow of Green Cube system for carbon aware scheduling of AI workloads in Kubernetes. The process begins with the user submitting an AI job and request in the form of a Kubernetes config map and marking as a pending job. So once it detects, the scheduler queries the carbon feed service to fetch the region-wise carbon intensity values, and it expresses in the CO2 per kilowatt hour. So based on this information, the scheduler runs on one of these two algorithms. GCM selects the region with the lowest carbon intensity, making it suitable for the batch and delay tolerant workloads. BCS, on the other hand, balances carbon reduction with latency constraints using a tunable parameter. Finally, we compare the outcomes of GCM and BCAs in terms of carbon efficiency and latency, demonstrating how carbon aware scheduling can reduce while maintaining performance. So, our system uses a fixed set of regions, time varying carbon intensity values, and a latency proxy. Job specifications are embedded inside these config maps. So, this keeps the architecture very lightweight and also extensible. So coming to our first Docker image, the carbon feed, it is a REST API built using Fast API. It exposes a list of variable regions and carbon intensity values. This acts as the carbon signal source for scheduling decisions. Coming to the schedulers, this is our second Docker image where the scheduler follows a controller and operator pattern. It monitors the config maps and presents the pending maps. Once detected, it fetches the carbon data and applies the algorithm and selects the target region. This creates the Kubernetes job with node affinity. This ensures the integration with the Kubernetes. Since the many literature review papers where we have conducted, we found that many of the real-time applications are based on CFDs, but we majorly focus on modifying the default schedulers, which reduces the portability and maintainability. So our control-based approach, it preserves the Kubernetes compatibility, and we can be deployed on any standard cluster without the cluster level changes. So coming to the AI inference job, this AI inference container, it processes an image data sets and writes predictions to the disk. The chosen region is injected as an environment available. This allows us to track where the job ran and why we are enabling the carbon analysis. So coming to our algorithm GCM, the greedy carbon minimization, we always place the job in the region or node with the lowest current carbon intensity. It is very simple, explainable, and also ideal for the batch and non-urgent jobs. However, it increases the latency if the cleanest region is very far away. So coming to the next algorithm, which is balanced carbon aware scheduling. Here we introduce a trade-off parameter alpha, which balances the carbon reductions, SLE, and latency constraints. Jobs are shifted only if the impact remains acceptable within the bound limits of the carbon intensity. So this makes our BCAS suitable for the production grade AI workloads. So it is very tunable, friendly, and also practical in production. So coming to the implementation of this project, this system runs in dedicated Kubernetes namespace with proper RBAC controls, and all interactions are handled through deployments, jobs, services, and config maps. No Kubernetes core components are modified, ensuring the portability. So here we would like to discuss the results. In our experiments, the AI job was automatically placed in EU North region, which had the lowest carbon intensity. This also confirms that the carbon signals were correctly ingested, and also the scheduling logic is also working as per the intention. The AI pipeline is also executed successfully. These config maps, they provide a very lightweight Kubernetes native trigger mechanism without defining new CRDs. So they allow the decoupling job of submission from the scheduling logic, and it keeps the scheduler very general and also which is very easily extensible. So these results are very key insights as per the project, and they validate that our carbon aware scheduling can be achieved without disrespecting the AI workflows. Since we have taken the data sets images as the workloads, the both GCM and BCAS successfully loads it and reduces the carbon impact while maintaining the execution. So coming to the final results, where each production has been shown. Each image has been run by the mobile VNet model, and it is done using the AI schedulers. So coming to the our future scope and limitations, these are the limitations which include the stimulated carbon data, and we also had limited regional scale. So this work can further include grid carbon data integration or multi-cloud supporting, and also large-scale AI models, also improving the scheduling algorithms. Whereas our proposed GCM and BCAS are the basic scheduling algorithms, we can further extend into DEMOS, MOCAS, or Casper algorithms. So these are the carbon-aware container lifecycle optimization, which can be further proceeded. Thank you. I would like to conclude my presentation.
Okay. Okay. So I have this question here about the carbon hour scheduling and the container lifetime. So I guess you have taken here multiple objectives, right? Your scheduling algorithm must be targeting multiple objectives.
Yes, ma'am.
So how you have achieved that? Like, have you proposed one objective function? So, like, is it a single objective function or a multi-objective function? Um, or you are giving more weightage to one objective than the other. So, about how you are achieving this objective.
Yes, ma'am. So here, actually, what we have proposed our work is the data set image has been taken as the AI workload, and we process it through a model that is mobile V2 model. So hence, this we now this application to get our results, we have proposed GCM and BCAS, where it chooses the best sustainable options, like the
How it
carbon
chooses that?
intensive.
Like, there
Yeah.
must be
So
some parameters based on which it will be
yes, ma'am.
choosing. So, I just want
So
to know that.
based on the yes, ma'am. Based on the region, latency, and carbon intensity, we have proposed this. We have a parameter called alpha, which prioritizes the carbon or either the latency. Since what happens is when a carbon aware region is very far from the current requested region, it majorly focuses on the latency. And when it is very nearby, it focuses on the timely temporal effects. So basically, our model, what it does is it already has the values of the carbon predictions and also the intensity values. Here, it picks up the regions with the score parameter. So we have proposed a formula with the parameters. So it picks the argument minimum score of that particular latency and carbon intensity.
So I guess you have not included that in the presentation, right?
Uh, Ma'am, we have included. I'll
That
just show you.
yeah, okay.
Mm.
One more thing is like, have you compared your algorithm to other such existing algorithms to validate your claim that you in your algorithm you are using the green system, but others they are more focusing on the latency one. So have you compared your work with some other similar works?
Ma'am, we actually compared our work during the literature review and then we have proposed it. Results also we have seen, but this is a different application and we have focused only on the basic scheduling algorithms.
Okay.
So that's the reason we have. And this is the function, ma'am,
Okay,
what we
okay.
have
This is
talking about.
your objective function.
Yes,
So
ma'am. Yes, ma'am.
you have taken your alpha for CIR and Y one minus alpha as the weight for latency.
Uh, Ma'am, it is actually a parameter, and this is the existing ones are what we have made this. So
This is already existing, this algorithm.
the weight is existing, ma'am.
Okay, okay. That's all from my
Like
side.
that
Thank you.
parameter of 1 minus alpha, it is an existing part.
Okay, 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 fine. Thank you.
Yes, ma'am.
Thank you, ma'am. I'd like to call upon our next paper presenter. We have Kavya Shri with the paper title Real-Time Mental Wellness AI Companion. Ma'am, if you're ready, then you may start with the presentation. Ma'am Kavya?
Hello.
Yeah, sir.
Am I audible?
Yes, sir, you're audible.
Kavya is not well, so I'll be presenting on behalf of her.
So
Is that
that is
fine?
completely okay. That is completely okay. You may go ahead.
I'm the co-author of the paper.
Okay. Okay, sir. Go ahead.
So, uh, good afternoon, everyone. Uh, we are from PES University from the Computer Science Department, and we have come up with this AI tool called Mental Wellness AI Companion, which is context aware emotional understanding with RAG based technology. So we know that there are a lot of mental issues going around, from stress to depression, from whatnot. Students are stressed, children are stressed, and so are adults. So we have come up with something to solve this issue and part of everyday well-being. So basically, we looked around, we saw chatbots. We saw that most of the chatbots are manual. You enter it gives you a response based on whatever you have given. But we have come up with voice input, and then it gives you a response based on what you've told it. Uh, by analyzing what you've told. So first, the system requirements, real-time text-based interaction for mental wellness support, the interface, but the context-aware conversation handling, where RAG, our radar system, and the stress detection by using decision trees comes. And then we have the analytical and design requirements, where we have emotion detection using sentiment analysis. We validated PHQ-9 response, which takes in all the inputs from all these stress analyzers and then gives an appropriate, very contextually aware response. So as I said, coming to the chatbot flows like ChatGPT or Gemini, where you have to type and everything, limited emotional adaptability and absence of clearly grounded responses. Most of it customized to your problems or your mental situation. And there are times when models hallucinate. And then privacy. Privacy is a situation with something like or bot. So cloud-based models, people can access your data, strict that you should not share your mental data with others. So that's why we have come up with a local LLM deployment, the 5.3 OLA, and it works customized only for you without giving out the data anywhere else. So yeah, this is the summary of the previous slide, which says text-based using Flask web interface, emotional tone detection using Vader sentiment analysis from NLTK, and then we have stress prediction using a decision tree classifier, and then we have a clinically validated. This was actually added to us by our uh, co-mentor who works in the mental health department. She's a head psychiatry in our hospital, hospital. And then we have added the additional things of RAG, which gives you a very contextually and clinic aware response.
So your voice is really lagging.
Oh, okay. Has it been for a while now?
So your PPT actually got disconnected, so you'll have to screen share again.
Okay, fine, I'll do that. Is it visible?
Yes, sir, it is visible now.
Uh, is- yeah, where did it stop last? Was I audible when I mentioned all the methodologies and workflows?
Yes, sir, you are audible. The voice was only lagging a bit.
Oh, okay, fine.
Yeah.
Okay. So now I'll go with the demonstration. This is the main UI where you log in or sign up, which is stored in the database. And then this is the clinically validated questionnaire, which I was talking about, which was recommended by our mentor, who's also the head of psychiatry in the PESU hospital. So responses are mapped to standard depression severity levels. It's clinically grounded assessment, which is necessary for anybody who has come with a mental illness or mental issues. And then is the stress questionnaire, which we were talking about to add more context to the chatbot, so that the PHQ-9 has only 9 questions, but this has some more questions which we have personally added, which has a particular rating. We've taken the data set from Kaggle, which is validated, and then where you give how often do you feel anxious, how do you have did you have a medical condition before, how often do you feel, so it adds more context to the existing worries. And then we have the main chatbot, meant the assistant, which takes in all the scores calculated from the stress questionnaire, the scores calculated from the PHQ-9 questionnaire, goes to the chatbot as a pretext or a context. So basically, in the prompt template, it is added and it is sent to the model to reply accordingly. So, and then 5.3 mini LLM generates empathetic, context aware, grounded responses locally. So the stress prediction is 87% with F1 score ranging between 0.84 to 0.89. We have high recall for the high stress category with sentiment detection accuracy greater than 90%. This usually takes about 2 to 3 seconds, and the response quality of the chatbot has improved after adding all the documents from WHO in the database. So it gives a very contextually accurate response. So yeah, coming to the end of the presentation, this is what we have learned. Emotional intelligence must be combined with clinical reliability in AI systems, unlike ChatGPT or Gemini, which is trained on a generalized data set, generalized data where you don't have customized responses. And RAG significantly reduces hallucinations and ensures clinically grounded responses. And on-device deployment has made sure that your data or your feelings or your issues are not sent out to anybody else. This is I conclude this. The latency of the chatbot response has to improve, because for now I think it's taking around 30 to 45 seconds to give a response. So deploy GPU enabled inference to reduce latency, extend it to mobile applications, and fine tune the LLMs much more so that they're more accurate and avoid hallucinations. Yeah, that's all from my side.
Thank you, sir. Ma'am, would you like to ask any question?
Yes, just one question from my side. In the beginning, during introduction, you talked about the data privacy. So, how you were achieving the data privacy here?
The model which gives out the responses is locally downloaded on your system. So it's not going to some cloud-based tool like ChatGPT or something. So there is no middleman for the data to go. There is the model inside your local system. It goes to and that is why the latency is so high, because it depends on the system. But yeah, that is why your data is private and secure.
But anyway, you were sending the data to the open RAG for to the RAG LLM for
Okay, coming to the RAG,
generating the responses. Yes.
Face is locally downloaded. So it basically creates memory in your own system. When you index the documents,
Mm-hmm.
what we have done this entire project on a single laptop.
Okay.
All the documents are indexed on a single laptop, and all the documents are present in the vector database of that system itself. So
Mm-hmm.
whenever you pass on the response, it goes to the same system's RAG and the database and gets you the response.
Okay. Okay. That's all from my side. Thank you.
Thank you, sir.
Yeah,
Thank you,
thank you.
ma'am. We'll be proceeding on with the next paper presenter. I'd like to call upon our Geeta with the paper titled Transforming Care with AI-Enabled CDSS, a survey of innovations, impact, and open problems. Ma'am, if you're ready, then you may start your presentation.
Ma'am, it's visible, ma'am?
Yes, ma'am, it is.
Good afternoon, everyone. This is Geeta. Today I'm going to present our work title name is Transforming Care with AI Clinical Decision Support System. This is based on the survey paper only. The survey is look into more than 90 reviewed paper between 2015 to 2025, focusing on how AI is reshaping the clinical decision support system. This mainly what is a clinical decision support system means. It is used to this clinical decision support system. It changed the rule-based tool into AI tool-based system. It helped the doctors take a better decision during the treatment, and it will reduce the errors and maintenance the healthcare efficiently. This changes, that is a rule based to AI in CDSS marketing in market. That growth is more in increase in future based on the patient demand and needs for the evidence-based care. Nowadays the patient they are asking explanation about their what doctor is going to do their treatment. They want a proper explanations. So this this client decision support system, by using AI platform, it will give explanation about treatment. For a patient also it will be useful, and for doctors also it will be useful. History for this client decision support system: in 1917 to 1980, this is a rule based system. For example, it is fixed as free-defined rules written by some expert. For example, the patient is having a cold, fever, or eye cough, means the doctor will suggest it is an eye fever based on this rule based, some knowledge based. But this system will not useful for complex cases. So in 1990 to 2000, integration phases started, that is in CDSS. The changes is done in the electronic health record. The electronic health record is changes is done during the doctors checking the patient record. The CDSS automatically it will check the patient report, any patient histories. It will display the patient histories, and recently any test result like a lab test or blood test, whatever is result, it will be displayed automatically. Based on that, doctor will take the decision what type of treatment or any alternate medicine is needed for that patient. Like that, by seeing that information, he will decide. But this phase is only used for real-time data in real patient data in the real time. It will not be applicable for a future. So in 2010, they introduced AI with an ML concept. So here it is on label. All the data will be labeled based on this ML concept, natural language processing. It will predict, and it will be classifications. For example, the system will analyze 1,000 X-ray result, past X-ray result. From that X-ray result, it will learn the patterns. For example, the lungs X-ray result means this model will learn the patterns, what type of each and every image, what type of the lungs, whether the lungs is extendable or it have more density. Based on that, it will give an classification, and it will predict this will happen for in future. Like that, it will predict. But in this at a time, only one task can be able to find in this AI in 2010 AML model. But in 2020 and 25, the foundation model is created, that is LLM and AI concept is introduced. In this the data will be unstructured client information. Based on that LLM and it based on the first it will understand and reasoning what is a problem, then it will generate the output based on that patient history, or if the doctor is helping this tool, means it will generate base for an doctors, and it will give a clear information about that result, and it will learn from new data. It will learn the information. This is with LLM, and it will give the clear information, explanation about that treatment or recommendation, whatever it is. It will give the clear information. The next is a history of the client decision support system. There are three architectures there. Now it is a knowledge based system. Already I explained the knowledge based system. It is few free defined rule bases already fixed, that is a knowledge use based logic. They will take that percent and decision tree model. Based on that, it will find out the well defined clinical protocol. For example, that blood pressure is more than 140/90, means the doctor will suggest it is having an hypertension. So it will have some rule base, also some decision tree model. The next architecture is a non-knowledge-based system. In this non-knowledge-based system, the rule-based logic, it will not be there. They will implement some, including some model like SVM or any CNN. Based on that, it will analyze and it will regenerate the output. For example, in this it will summarize the patient history also by using all this model. The next is a hybrid system. It is combined of the both the knowledge based and non-knowledge based systems. The next is what is this EHR, that is electronic health research. In this, what is the drawback of this EHR means the data model. For example, each vendor of EHR vendor will have an own structures. They will have an own the data will store in the some own structures. The patient, for example, some vendors they will write the blood pressure BP underscore readings. Few they will write as a blood pressure underscore reading. So this will be creating the data fragmentation. It is difficult for a CDSS to access the data. Next one is a data quality issues. Some main challenges is incomplete records, it will be there. In that cases it is very difficult, the data quality issues will be created. So it is very difficult to understand that problems. The next is a custom development burden. Each CDSS often need a platform specific customization to integrate with each ESHR system. Means, for example, each vendor is required as their own structures. So for customizing the CDSS, it will be very difficult. It will require the development cost also, it will be more, and reducing the scalability also it will be there. So compare now in this our modern interoperate standards. This EHR will be adapted 98% percentage of the FAIR adaptation. In that common format it will be there. What are the common format or protocol they will maintain? Based on that, all the patient records or patient data, it will be stored in the common format, or it will be in a common protocol. One more is 50% is they are using a web-based health data exchange, because the EHR is adapted this FAIR adaptation. In that, data need to be exchanged from one system to one more system. So the security is needed. So they are using a standard web-based health data exchange. That is 50%. The next is 80%. That is a substitutable medical application research techniques on FAIR. In this in this it will be plug and play the clinical app that can be access the patient data in the real time inside in the EHR. Inside in the EHR, they can able to access the patient real time data with the more security. This is more advantage of this CDS with AI and LL model. These are the field where CDS is mainly used in this. Based on that, the doctor can, if this CDS is mainly used in the primary care, if they are used this AI tool in this primary care means, based on their recommendation, based on the tool recommendation, doctor will decide what type of treatment we can give for a patient. This is mainly in this system the evaluation matrix they are using, because the true positive ratio should be more and true negative ratio should be less. In AUC, that is area under the curve. This area under the curve, it will tell how this model can be differentiate between the patient with and without diseases, possibilities, decision making, it will explain here. Then the patient is having a safety, that HUS scale it will be evaluated as properly. Then these are the, while constructing this support system, these are the ethics we should follow. It should have a proper framework and extendable AI should be there. and algorithm bias should be they should follow the properly. These are the ethics they should follow while creating the CDSS system. Then what is the use of language LLM model in a CDSS system means it will give the analyze the patient report properly. It will summarize the patient histories. For example, the patient before they checked with one doctor, they will have some summary. They want to change the doctor. That time this model will give proper summary of this patient result properly, and it will help the doctors assign the it will help the doctor during the treatment. It will support the treatment recommendation also it will do of. And these are the challenges it is there in this field. Technical for clinical integration, these are the challenges in when we are doing the research direction or open challenges. And from final conclusion, with the help of this CDSS, that is move from the rule based to AI tool, it will give the proper explanation, or it will give the proper recommendation to doctor what type of treatment they can take over for the patient, and it will reduce the error base also, and it will give more privacy in data exchange between the systems, and it will act as a focus on human AI collaboration. And it usually in the research, in the future research, what means so far we are sending the data only in the text or X-ray in image. In future, multimodal data can be used, either a text to it will convert it into an audio, or audio it will convert it into text, or video it will be converted into an text. All these it is possibilities by using an LLM model. Thank you.
So, a simple question from my side is when the CDSS shifted from the traditional techniques to AI-based techniques, what do you think, like what limitations or challenges newly came that one should be aware about when using AI-based CDSS?
Yes, ma'am. What
What challenges or limitations one should be aware about, which were not previously there when traditional CDSs were used, and now AI or LLM based CDSs, with AI or LLM based CDSs, these new challenges have come up. So,
Yes,
what?
ma'am. It's
Yeah. So,
actually before it is traditional CDSS. This what is it? It will be summarize only the text. It will not convert this text into an multi-mode concept. It is not there. But by using this LLM CDSS or AI
no, that is the advantage. I'm talking about the disadvantages or the limitations that has come up with the AI or LLM based
a
CDSs.
limitation means mainly it will be an data security set. For example, patient will not ready to give their data like what to do. They will not ready to relieve their data. That will be a challenge in this things.
Okay, okay, thank you.
Thank you.
Thank you, ma'am. We'll be proceeding on to our next presenter. I'd like to call upon Pema Galmo with the paper titled Volumetric Liver Tumor Segmentation Using 3D UNet and GAN Refinement. Ma'am, if you're ready, then you may go ahead. Ma'am Pema?
Hello.
Yeah.
Wait. Is my screen visible? Hello?
Yes, ma'am, it is visible.
Okay. Good afternoon, everyone. Respected session chair, honorable judges, and dear participants. I am Pema Galmu Sherpa from the Department of Computer Science and Engineering from Sikkim Manipal Institute of Technology, Sikkim. Today, I am pleased to present our work titled Volumetric Liver Tumor Segmentation using 3D Unit and GAN Refinement. These are the content of our today's presentation. which includes introduction, problem definition, solution strategy, proposed methodology, dataset description, tools for implementation, quantitative result and qualitative result, conclusion and future work, and lastly, references. To begin with introduction, accurate liver segmentation, which includes the identification of liver tumor, it's a crucial task in medical imaging analysis, particularly for diagnosis and surgical planning and treatment monitoring. So, CT imaging is widely used for liver examination due to its high spatial resolution. However, segmenting the liver tumor from CT scan remains challenging because of the low contrast between the tumor and healthy tissue, irregular tumor shapes, and sometimes high variability across the patients. So, so traditional segmentation techniques and even some deep learning models, they often fail to produce precise tumor boundaries. Therefore, this research aims to improve the accuracy and automation of liver tumor segmentation by combining 3D unit architecture with GAN based refinement to achieve a better boundary delineation and reduced false positive. These are some of the problem definitions. Proper liver tumor segmentation from CT volume is really critical for any clinical diagnosis and surgical planning. To manually tumor delineation, it's time consuming and subjective and often prone to inter and intra observer variability, which makes it unsuitable for large scale or real time clinical application. So, from an imaging perspective, CT scan they frequently exhibit low contrast between tumor tissue and surrounding liver, along with the tumor appearances, which is characterized by irregular shapes and diverse intensity distribution. Consequently, existing approaches may achieve reasonable volumetric localization, but they often fail to deliver the boundary precision which is required for accurate tumor and surgical planning. Therefore, the core problem addressed in this work is the need for a robust automated segmentation framework that preserves volumetric context while simultaneously enhancing boundary delineation and reducing the false positive predictions in liver tumor segmentation from 3D CT data. Now, to address these challenges for accurately liver tumor segmentation from CT volumes, we propose a hybrid deep learning framework that integrates volumetric feature learning with the adversarial GAN refinement. The solution firstly begins with comprehensive preprocessing of CT volumes that includes intensity clipping based on Hounsfield unit, following normalization, and then resampling to uniform voxel spacing and data augmentation to reduce the interpatient variability and improved model generalization. Then a 3D unit architecture, which is our base architecture, it is then employed to learn the hierarchical, volumetric, and interslice contextual features to generate a initial voxel-wise tumor probability map. Uh, this network effectively captures global tumor localization. Its output may still contain some blurred or boundary or some false positive region. So to overcome this limitation, GAN-based refinement model is introduced where discriminator network enforces a structural and boundary level consistency by distinguishing refined segmentation output from ground truth marks. The effectiveness of this proposed strategy is quantitatively evaluated using some of the matrices like dice similarity coefficient and Jaccard index, and qualitatively validated through visual inspection of segmentation results. This is our proposed methodology. It firstly operates on a 3D abdominal CT volume with the corresponding ground truth tumor mask, which is followed by a multi-stage pipeline. So I'll explain this proposed methodology with the following diagram. This is the methodology diagram. Initially, the input CT scan, it undergoes preprocessing, which includes steps like Wunsfeld unit windowing, which is used to suppress the irrelevant intensity ranges, and then intensity normalization and spatial resembling to achieve a uniform voxel resolution, and data augmentation, which is used to improve the robustness against variability. The preprocessed volume are then fed into our architecture in a 3D unit encoder decoder architecture with skip connections. This is skip connections which enables effective extraction of the hierarchical volumetric features while it still preserves the spatial context across the slices, which is an advantage. This network then generates an initial voxel-wise probability map for the liver tumor segmentation. To address these limitations of the boundary smoothness and false positive predictions in segmentation network, a GAN-based refinement stage is then incorporated, where the segmentation network it acts as the generator and a discriminator network, which evaluates the realism of predicted mask relative to the ground truth annotations. The entire framework is then trained end to end using a composite loss function which combines the segmentation loss with the adversarial loss, both pixel-wise accuracy and structural consistency. So finally, the refined segmentation output is thresholded to obtain a binary tumor mask, and a model performance is assessed using evaluation matrices like dice similarity coefficient and Jaccard index, which is complemented by qualitative visual analysis. Dataset description. The experiment in this study were conducted using the 3D liver and liver tumor segmentation dataset, which we obtained from the Kaggle, and it's derived from the LITS, which is liver tumor segmentation challenge. The number of volume in this dataset was 123 pairs of CT volume, which is acquired using CT or computed tomography, and the format was in Nifty. Each volume includes the pixel-wise annotation for liver tumor. Now, to ensure the memory efficient training and effective volumetric learning, the CT scans were divided into a patches of size 128 by 128 by 128, and the dataset was split into 86 volume for training, 24 for validation, and 13 for testing, which is for ensuring proper evaluation of model generalization across unseen data. Now, moving on for tools for implementation. The proposed framework was implemented using Python as the primary programming language, and PyTorch was employed as the deep learning framework for designing and training the 3D unit and GAN model. Now, medical imaging preprocessing and volume handling were performed using libraries like Nibabel and Simple ITK, and NumPy for numerical computation. Now, for the visualization part, the output visualization segmentation output part was carried out using the matplot, and all these experiments were executed in Jupyter Notebook environment, which is to support the efficient training of 3D convolutional network. Moving on with the quantitative result, this table compares the segmentation performance of several existing approaches with the proposed model using the dice similarity and Jaccard index. Here, the proposed 3D unit plus GAN, it acquired a diced percentage of 90.7 and the Jaccard of 82.5. We can see that our proposed 3D unit model outperformed the other model which I compared, like CSFCM 2D FCN or unit, or just a base 3D unit and hybrid of 2D and 3D. Now the qualitative result. In this figure, we can see there are 4 different types of preprocessing stages. Now, in the first subfigure, it shows the original axial CT slice, which contains a wide range of intensity, values, and background structure that are not relevant for any liver tumor segmentation task. Moving on to the next subfigure B, which is Hounsfield Hounsfield unit windowing is applied here to enhance the liver tissue contrast, which suppresses the irrelevant intensity ranges such as bones and the air. This step is crucial because it improves the visibility of liver structures and tumor regions. In the subfigure C, which represents the extracted liver mask, which isolates the liver region from the surrounding organs and reduces the background interference during tumor segmentation. And the subfigure D, it shows the corresponding tumor mask while highlighting the annotated tumor regions, which is used for ground truth for supervised learning. And finally, the subfigure E, it presents the overlay of liver and tumor on the CT images, which demonstrates the spatial relationship between the liver anatomy and the tumor location. This all the visualization confirms the accuracy of the annotations of the preprocessing pipeline. This pipeline is really important because it ensures that the segmentation model just focuses on the clinically relevant regions and reduces the noise and intensity variability, which is important for both training stability and segmentation accuracy. Now, the next figure 3, which is the comparison of model prediction. Here we can see that it's a visual comparison between the baseline 3D unit prediction and the GAN refined segmentation, and the difference between two output, each overlaid with the ground truth annotation. The left image shows that the segmentation produced by the baseline 3D unit overlaid with the ground truth tumor mask. While the model successfully it localizes the tumor region, the predicted boundary it appears slightly irregular, and it includes a minor boundary leakage, indicating over segmentation and reduced edge precision. The middle image it presents the GAN refined segmentation overlaid with the ground truth. Here we can see that the tumor boundaries they are noticeably sharper and more compact with the alignment to the ground truth mask. And the rightmost image it highlights the pixel-wise difference between the 3D unit output and the GAN refined prediction. Overall, this figure 3 it visually confirms that GAN-based refinement enhances boundary accuracy and reduces false positive predictions comparatively to the baseline 3D unit, which is consistent with observed improvements.
Excuse me, ma'am. I'm
Yes.
really sorry to interrupt you, but I'd like to remind you of the time limit.
Okay.
Yeah.
Now the figure 3, which is the training and validation loss curves of the 3D unit model, it shows that the training loss shows a steady and consistent decrease, indicating the effective learning of the volumetric features from the CT data. Similarly, the validation loss here we can see that it follows a downward trend, suggests that the model was generalized well to unseen data. So based on these results, now I would like to summarize the key conclusion and future directions of this work. So in this work, we proposed a hybrid deep learning framework which combined both 3D unit architecture with GAN-based refinement for volumetric liver tumor segmentation. The integration of the adversarial refinement significantly improved liver tumor accuracy as we got of 90% and Jaccard index of 82%, which confirms both qualitative and quantitative improvements in segmentation performance. So as for future work, this framework it can be extended by incorporating some transformer based architecture to capture long range dependencies, or performing cross dataset evaluation to assess the generalization across different imaging protocols. So these detections aim to further enhance the robustness and the clinical applicability of the automated liver tumor segmentation systems. So these are some of the references which include key research works related to liver and tumor segmentation. These studies, they provided the foundational concept and methodological insights that guided the development and evaluation of our proper proposed framework. So lastly, I would like to thank the SMARTCOM 2026 committee and the reviewers for giving me this chance to present my work. Thank you for all your time and attention.
Okay, so can you just say, like, justify why you used the unit model only?
So, unit model, it's a base model for medical image task because it follows a encoder decoder uh, architecture, which is very important for volumetric feature extraction, which improves the model training and stability. So, in comparison with any other ML models or any deep learning models, this unit model is like it performs better than the other ML model and the deep learning models. So just because of the volumetric extraction and better feature extraction for model stability, I used this unit.
Have you accessed the computational resources used and the time it takes for doing the classification work?
No, for the time computational part, ma'am, I have just observed that training time, the model takes it was bit higher than the just base unit. So training time, I faced some challenges during the training time. Uh, I would like to suggest that for a better time computation, uh, the resources that needed are strong GPU. If you have strong GPU and well GPU enhanced system, you can just overcome this time problem.
But then this makes the work questionable if to be used in the real time, because in real time, definitely we have the time constraint and space constraint.
Yes, ma'am. So for that also, ma'am, if we have some good GPU and some strong machines, so if the if the machines are well strong enough and if the GPU is better, so handling the real time problem, it would be like better than in just like applying in just in like random things, ma'am.
Okay, okay. Okay, thank you. That's all from my side.
Thank you, ma'am.
Thank you, ma'am. I'd like to request Ma'am Chetna to present the paper. Ma'am, if you're ready now.
Yes, ma'am.
Yeah.
Are you able to see my screen?
Yes, ma'am, it is visible.
Good afternoon, everyone. And respected chairperson, honorable judges, faculty members, and dear researchers. Myself, Chetna Chowdhury from School of Engineering and Technology, Sanjeev Agrawal Global Educational University, Bhopal. Today, I'm going to present my research work titled Novel Lightweight CNN Architecture for Accurate Classification of ECG Images in the Cardiovascular Disease Diagnosis. This is the outline of my PPTs, objectives, motivation, introduction, literature, proposed methodology, result, and conclusion. This is my abstract. Uh, this is the cardiovascular disease, one of the leading cause of the death worldwide. Early detection and accurate classification play a very important role in saving lives. And ECG is a low-cost, non-invasive, and widely used tool to measure an electrical activity of the heart. In this research area, we use a deep learning technique to classify ECG images using the following four classes. That is the first one is a normal person, abnormal heart rate, myocardial infarction, history of myocardial infarction. Uh, we propose a novel lightweight CNN architecture, which is the proposed one, that improve accuracy by reducing a computational complexity. The proposed model is also compared with a pre-trained deep learning model to demonstrate the effectiveness. Objective. Uh, Basically, this is the objective of my research area. First one to study and analyze ECG images dataset related to cardiovascular disease, to apply the machine learning and deep learning techniques for ECG image classification, to develop and optimize an accurate CNN model, to compare the proposed model with existing state-of-art methods. Uh, so the motivation behind this research comes from the growing under the cardiovascular disease cases and the limitation of manual diagnosis. Manual ECG interpretation is a time-consuming, error-prone, and highly dependent on the expert knowledge. There is a strong need of the automated system that is to analyze ECG images effectively, reduce human error, assist clinical decision making. By designing the CNN specifically and important ECG images, we aim to improve generalization capacity, speed, and the accuracy, and compare it with the other machine learning approaches. The introduction part. In introduction, basically, cardiovascular disease are the recognized as a leading cause of the mortality, making early prediction extremely important. ECG play a key role in diagnosing the heart disease by capturing the electrical signals of the heart. In this study, we explore the transfer learning approaches using a pre-trained model such as LXNet, Exception, and DenseNet 201. A novel CNN architecture specifically designed for the ECG image classification. The focus to classify the four cardiac conditions with a high accuracy and reliability. This is the introduction. In addition, there is a deep learning classification. We use a CNN model, proposed CNN model, uh, uh, as a feature extraction. These extraction features are fed into the traditional machine learning classifications such as the SVM, KNN, decision tree, random forest, naive Bayes. Experimental result shows a proposed CNN outperform all other models, achieving a 90, which is a 98.23 percentage accuracy using CNN. And the CNN combines with a naive Bayes, so it's giving a 99.79 percentage accuracy. Mm. Next is a literature survey. In literature survey, in PPT, I included 6 papers. In the literature survey, we studied several recent research work related to ECG-based cardiovascular disease detection. Previous study have applied a different machine learning techniques, deep learning architectures, hybrid CNN-based models. However, many existing methods suffer from high computational uh, high computational complexity, limited generalization, lower accuracy on a ECG image dataset. This gap motivated us to develop and lightweight and efficient CNN architectures that can achieve a higher accuracy with a reduced complexity. This is all the literature survey paper. I included the 6 papers in the literature survey. Next is the proposed methodology diagram. In the proposed methodology diagram, this is the different steps. Our proposed methodology consists of the in the proposed methodology diagram. You can see that the the process begins with a ECG image preprocessing that includes copying, resizing, data augmentation. Then the image passed through a proposed 38-layer light-fit CNN model, retrained deep learning model using a transfer learning. The extracted features are then finally classified into the four cardio categories, that is age, HMI, MI, and NP, as we discussed previously. Proposed methodology in the in diagram we can see our proposed model consists of the two branches, which is a stack branch and full branch. This branch helps in extracting the both local and global feature from the ECG images. In addition, pre-trained models such as the AlexNet, Exception, and the DenseNet 201 are used for the feature extraction. Traditional classifiers like SVM, KNN, DT, RF, and naive Bayes are applied to the final stage to improve classification performance methodology. Uh, Next, the proposed lightweight CNN model is a clinical decision support tool. It helps to reduce a burden of medical professionals, minimize the diagnosis error, save time in ECG interpretation. The model can be used as a feature extractor for uh, machine learning classifiers, improve their accuracy. This approach contributes to early detections, better treatment planning, and reduced healthcare cost. Uh, Next slide is the result. The proposed CNN, you can see there is a bar graph is there. On the proposed CNN is gives a very good accuracy, which is a 98.23%, and others, AlexNet exception and the DenseNet 201 outperforms. This demonstrates the robustness and the effectiveness of the proposed architecture. Next one is the conclusion. Uh, to conclude, a novel lighter CNN architecture is proposed for a ECG classification. The model achieves excellent accuracy and performance. It can effectively use a feature extraction tool. The system can assist clinicals in early and accurate diagnosis. Overall, the research highlights the significant role in AI in healthcare, especially in early detection of cardiovascular disease. Um, the next one is the future scope. In this future, we can work with external in several dimensions. The model can be applied over other medical image classification problem. It can integrate into a industrial IT environment. Real-time and embedded system implementations can be explored. This extension can be further to enhance the practical usability. This is the references of mine. And thank you, all of you. Thank you all of you for your time and attention. I would like, thank you.
Okay. So can you just highlight the hyperparameters that you have taken for your CNN model? Value of hyperparameters.
This is the CNN model.
I'm talking about the hyperparameters like which activation functions you have used, what's the stride rate, how many hidden layers you have chosen for your CNN model.
Mm, Sorry, ma'am.
Okay. So regarding the computational complexity or the time complexity, have you done any assessment regarding that?
No, ma'am.
Okay. Okay. Thank you. That's all from my side.
Thank you, ma'am. This brings us to the end of the session. I'd like to sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version of and all the previous 9 versions of the conference. We would be happy to have you in the 11th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCon 2026. Furthermore, I'd also like to thank our session chair for chairing this session. A token to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Thank you so much.
Thank you, ma'am. Just before we end the session, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone.